Hello, in this video, we are going to discuss the activity from the Unit 1 Matrix B, and we are going to discuss activity 3C, determining chemical formulas. So by now you should have already watched the video and taken note on determining chemical formulas, but we're going to go through this worksheet together in case you need to see more example problems. So in order to do this, you're going to need both your worksheet and a periodic table. And if you don't already know your polyatomic ions, then have your list of polyatomic ions in front of you. The first one is magnesium phosphide, and this ending IDE indicates that it is the element phosphorus. So we just need to have our magnesium ion and our phosphide ion. So we need to figure out those charges by looking at the periodic table, and you can label your periodic table +1, +2, +3, and then -1, -2, -3 if you would like. But remember, on a quiz or test, you do need to use one of the blank periodic tables, so you need to be able to remember what charge each group of the periodic table has. So magnesium is in group 2, has a +2 charge on its ion. And then phosphorus is over here in group 15. It has a -3 charge on its ion. So we're just going to use our crisscross method to figure out our formula. 3 comes down to become the subscript on magnesium. And then our 2 comes down and becomes the subscript on phosphorus. So Mg3P2. Next we have beryllium chloride. So beryllium, I know the symbol is Be. Oh, move that up for you. Beryllium is Be, and then chloride, that IDE indicates that's the element chlorine. So I'm going to go ahead and write Cl down here. Then let's look at our periodic table to figure out our charges. Beryllium is also in group 2, so I'm going to put a +2 charge on beryllium. And then chlorine is over here in group 17. It's a halogen, so it has a -1 charge. When we cross down, I'm going to put Be, and remember we can cross down this 1 here and write it down. We have 1 beryllium, and then we cross down this 2 and it becomes the subscript on chlorine. But it is not correct to show a 1 in our chemical formula because it's implied. So I'm going to rewrite this as just BeCl2. That's my final answer. Next up we have cesium oxide. Cesium is Cs, and then oxide, that IDE, indicates that it's the element oxygen. Oxygen's a little bit of a weird root. It's just the ox part. You don't use the egen part. That whole thing gets removed. It's oxide. So looking at our periodic table, cesium is in group 1, so it's got a +1 oxidation state, and then oxygen is in group 16, giving it a -2 charge. We do our crisscross. The 2 on oxygen becomes the subscript for cesium, and then oxygen gets a subscript of 1, which we know we don't show that 1, so I'm going to rewrite this as CS2O, cesium oxide. Next we have beryllium phosphide. So beryllium is Be, and then phosphide, meaning the element phosphorus. So I'm going to put P for phosphorus. Beryllium is in group 2 of the periodic table, so it has a +2 charge. +2. And then phosphorus is over here in group 15, meaning it has a -3 charge. We're going to go ahead and do our crisscross. So beryllium takes this 3 as its subscript, and then phosphorus, this 2 comes down and becomes the subscript on phosphorus. Be3P2, beryllium phosphide. Next we have boron sulfide. Boron symbol is just B, and sulfide, meaning the element sulfur, which is capital S. We need to find our charges. Boron is all the way over here in group 13, so it has a +3 charge, +3, and sulfur is over here in group 16, it has a -2 charge. So we're going to do our crisscross. Boron, this 2 comes down as the subscript, and then sulfur, this 3 comes down as the subscript for sulfur. Next we have barium fluoride. Barium, Ba. Fluoride, meaning it's fluorine with just the capital F. Barium is in group 2 with a +2 charge. And fluorine is over in group 17 with a -1 charge. When we do our crisscross, this time I'm not going to write that 1 down. I'm just going to show that arrow, and then I'm not going to write that 1 because I know that I don't have to show a 1. It is implied. Then fluorine, this 2 comes down, and I do have to show that 2. BaF2, barium fluoride. Next we have silver nitride. Silver is Ag. Nitride, meaning the "ide" indicates it's an element nitrogen. Nitrogen. Silver is kind of a tricky one because it is over in the transition metals, but silver always has the same oxidation state. It's always +1. Which actually it says up in the corner of my periodic table here, but you do need to remember that it is +1 every single time. So silver is going to be +1. Nitrogen, I can come over here and find in group 15 has a -3 charge. So nitrogen, let's straighten this out for you, has a -3 oxidation state. So when I do my crisscross, I'm going to get this 3 coming down, Ag3, and then in this 1's going to come down, but I'm not going to write that 1 because I know it is implied. Then last in this column we have zinc phosphide. Zinc is Zn, and then phosphide, meaning phosphorus, capital P. Zinc is another tricky one, as it is also in the transition metal section, but it always has the same oxidation state of +2. +2, and you do need to remember that. The other tricky one is cadmium, which also has a +2 oxidation state. So zinc is +2, and then zinc is +2, and phosphorus has a -3 oxidation state. When we do our crisscross here, we get Zn. This 3 comes down, Zn3, and then P2. Next up, we have cadmium chloride. Cadmium is Cd, chlorine is Cl. So cadmium is that last tricky one that we were talking about with a +2 oxidation state. And of course chlorine is over in the halogens with a -1 oxidation state. So +2, -1. When we do our crisscross, we get Cd with this 1 coming down. I'm not going to write it though because it's implied. And then Cl with this 2 coming down. Next, we have copper 2 chloride. So remember, copper is a transition metal, Cu. So it has multiple oxidation states. And this periodic table actually shows that it has oxidation states of both +1 and +2. So metals are always going to be positive charges. They're always cations. So I know that this 2 that's in parentheses tells me what the charge of copper is. So I'm going to put Cu, and I know that because it shows a Roman numeral 2 that the charge is +2. And then chlorine is because a halogen has a charge of -1. When I do my crisscross the exact same way, so I'm going to do Cu with this 1 coming down, and then Cl with this 2. CuCl2, copper 2 chloride. Next we have iron 2 oxide. So iron is Fe. I know this 2 indicates that it has a +2 charge. Then oxygen. Oxygen has a -2 charge. It's in group 16, a -2 charge. So I'm going to do my crisscross, Fe with the 2 coming down, and then O, also with a 2 coming down. When I wind up with a formula like this, if I can divide these by the same value and kind of reduce my formula, then I have to do that. This is not a correct way of showing an ionic formula. Ionic formulas are repetitive because ionic substances exist in repetitive crystalline structures. So when we show the formula, we show the reduced version. So here, both iron and oxygen have 2, and I can divide both these by 2. So I'm going to do that and reduce my formula and instead show it just as FeO, Fe1O1, but we don't show those ones. So this is the correct final formula here, FeO. Next we have copper 1 chloride. Copper is Cu, and I know this tells me I have a +1 charge. And then chlorine is over in the halogens. Chlorine is here, so it has a -1 charge. So when I do my crisscross, Cu is going to get a 1, but we're not going to show that 1. And then Cl is also going to get a 1, but it's also not going to be shown. They are both implied. Next we have iron 3 oxide. Iron is Fe. And then this 3 indicates that it's a +3 oxidation state. And then oxide, meaning oxygen. Oxygen has a -2 oxidation state. So when I do my crisscross, I end up with 2 irons and 3 oxygens. Next we have manganese 2 nitride. Manganese is Mn, not magnesium, but manganese, and it has a +2 charge on it, based on that Roman numeral. And then nitride, meaning nitrogen. So nitrogen is going to have a -3 charge. Nitrogen -3. I'm going to do my crisscross, Mn, and this 3 is going to come down, and then N, and this 2 is going to come down here. Mn3, N2. Next we have molybdenum 2 fluoride. Molybdenum is kind of a funny one on the periodic table. It is actually Mo for molybdenum. It's number 42 right here in the transition metals. Molybdenum, Mo, with a +2 oxidation state. And then fluorine, fluoride ion, which is a halogen, has a -1 oxidation state. Then we do our crisscross, Mo, and there's one of those, but we're not going to show that one. And then fluorine gets that 2. So MoF2 is our formula. Next we have nickel 3 oxide. Nickel is Ni, and it has that +3 oxidation state. And then oxygen. Oxygen's here in group 16 with a -2 charge. So Ni gets this 2, it crosses down, and then O gets this 3 crossing down. Ni2O3. Next we have sodium bromide. Sodium is another funny symbol. It's Na, but that's one that you should know. And then bromine is going to be Br. Sodium is in group 1, giving it a +1 oxidation state. And bromine is in group 17, which gives it a -1 oxidation state. Then we do our crisscross in A with the 1 coming down, but we're not showing it. And then Br also with a 1 that's not shown. Next we have vanadium 5-phosphate. Vanadium is a capital V. And then this V is the Roman numeral 5, so I know it has a +5 oxidation state. And then this time we don't have an ending of "ide," we have an ending of 8, ATE. And that indicates that it is a polyatomic ion. And more so than that, it indicates it's the polyatomic ion phosphate, because when we name, we just keep the name of our polyatomic ion. If you don't know your polyatomic ions yet, then I would encourage you to refer to your list of common polyatomic ions. And then see right here we have phosphate, which is PO4 with a -3 charge. You do need to memorize these, however. They're very important for being able to write correct chemical formulas. So phosphate is PO4, I'm going to put in parentheses 3-. When I do my crisscross, the only difference here is how we're going to crisscross for our phosphate. So the first part's the same. This 3 comes down and becomes the subscript for vanadium. And then when this 5 comes down, it means that we have 5 of the whole phosphate ion. So we need to keep it in the parentheses to indicate that we have PO4 and then we have that ion 5 times. So here we have V3, PO4, and then parentheses with a 5 outside the parentheses. Now, if we only had one phosphate, then the parentheses would not be necessary. But since we have more than one phosphate ion, we need to put the parentheses around the phosphate to indicate that we have 5 of this whole phosphate ion. Next we have silver iodide, silver being Ag. And we already talked about that being one of the ones that you need to memorize. Silver is a transition metal, but it always has the same oxidation state of +1. And then iodine, that IDE indicates that it's the element iodine, which is in group 17 and has a -1 charge. We do our crisscross, Ag, 1 comes down, but we don't show that 1. Then iodine, 1 also comes down, but we don't show that 1. AgI, silver iodide. Next we have niobium 3-oxide. Niobium is another funny one. It's in the transition metals section right here. Niobium in B has a +3 oxidation state according to our Roman numeral, and then oxide, meaning oxygen, which is here in group 16, has a -2 oxidation state. We do our crisscross in B, we cross this 2 down to become the subscript, and then oxygen, we cross this 3 down to become the subscript on oxygen. Next, palladium 4-fluoride, this Roman numeral 4 IV. Now, if we had VI, that would be a Roman numeral 6. So make sure you know your Roman numerals. Palladium is PD. PD on the periodic table, right here, palladium, number 46, in the transition metals section. Palladium with a +4 charge, and then fluoride, so fluorine, and then it, of course, has a -1 charge. So PD, this 1 crosses down, but we don't show that 1. And then fluorine, with this 4 crossing down. So PdF4, palladium 4-fluoride. Next we have mercury 4-selenide, which selenide is kind of a weird one too. That is the selenium ion, the -2 charge. Mercury is, of course, Hg, and I like to remember that because it rhymes. Hg is mercury, kind of rhymes. So mercury, Hg, has a +4 charge, and then selenium has a -2 charge. So we do our crisscross, we get Hg2, and then S with that 4 coming down. And looking at these, 2 and 4 are both divisible by the same number. They're both divisible by 2. So I need to reduce this chemical formula. So I reduce this to HgS2, reducing our chemical formula. Next, we have platinum 2 oxide. Platinum is Pt. 2 means it has a +2 oxidation state. And then oxygen, of course, has a -2 oxidation state. When we do our crisscross, we have Pt2 and then O with that 2 coming down. And of course, we need to reduce this formula. Pt2, O2 can reduce to just PtO. Finally, we have iridium 3 chloride. Iridium, IR. Let me show you where that is on the periodic table. Iridium, number 77. So iridium 3 chloride has a +3 charge, and then chlorine, Cl, has a -1 charge. When we do our crisscross, we get iridium, one of those, which we don't show that one, and then chlorine gets this 3, IrCl3. And now we're going to look at the back of our worksheet. So we're going to look at writing formulas for covalent compounds first. So remember, covalent compounds have the number written in the name. So with these prefixes, we show how many of each nonmetal we have. So di is the prefix, meaning 2, and tri is the prefix, meaning 3. So this means we have 2 nitrogens and 3 oxygens. So I'm going to write N2O3. So covalent compounds are really easy to write the formulas because the name literally tells you how many of each element you have. Next we have sulfur pentoxide. So pent is the prefix meaning 5. And then sulfur doesn't have a prefix, so we know that there is 1 sulfur. We don't put a prefix on the first part of a covalent name if there's only 1. So sulfur, there's just 1 sulfur. And then oxygen, there are 5 of those. SO5, sulfur pentoxide. Then carbon tetrachloride. So there's no prefix, so we know there's 1 carbon. And tetrachloride, tetra being the prefix meaning 4. So we have 4 chlorines and 1 carbon. Carbon Cl4. CCl4, carbon tetrachloride. Triphosphorus nonoxide. So tri means 3. And then nona, or for oxygen, we shorten it to nonoxide. So it means 9. So we have 3 phosphoruses and 9 oxygens. And you might be looking at this and saying, oh, well, you can reduce that. But in a covalent compound, we do not reduce our formulas. It is not the same as with ionic substances. We are showing exactly how many of each element we have, not just the ratio of the elements. We leave this as 3 phosphoruses and 9 oxygens. Then we have pentasulfur octachloride. So pentasulfur, penta meaning 5, octa, of course, meaning 8. Think about an octopus. Pentasulfur, so S5, Cl8. And then last we have oxygen heptabromide. There's no prefix, so we know there's 1 oxygen. And then hepta means 7. Hepta meaning 7. So we have O, and then bromine, and 7 bromines. OBr7. And then the last part of this whole writing formulas is with acids. And acids, as we talked about in our video, have some weird naming rules, but once you learn the rules, it's pretty easy to determine the formula. So let's look at these examples. So hydrosulfuric acid. So this hydro prefix means that we're talking about the element sulfur, not the polyatomic ion. So hydrosulfuric acid, acids always start with hydrogen, H plus 1, and then we also have the sulfide ion because it's hydrosulfuric acid. So sulfur has a -2 charge. And then with acids we do use our crisscross method. So we have H, and this 2 comes down as the subscript on the hydrogen. And then you're always just going to have one of the second element or substance in your acid because hydrogen has a +1 oxidation state. So you're always going to be crossing down a 1, which you don't need to show. Next we have sulfuric acid. So there's no hydro prefix. So the lack of a hydro prefix indicates that it's a polyatomic ion. And since it ends in ic, we knew that this came from the polyatomic ion that ended in 8. And if you forget that, I put those notes up here for you. If it ends in ic, then the polyatomic ion ended in 8. So coming over to our list, in case you don't know your polyatomic ions yet, so we're looking for the polyatomic that contains sulfur and ended in 8. That would be the sulfate ion, SO4 2-. So I'm going to write that first so I don't forget, SO4 2-, and then my first element is of course going to be hydrogen, H+. So we are going to do our crisscross. This 2 comes down here, H2, and then it's just going to be +1, so we only have one SO4, one sulfate. Then we have sulfurous acid. So that OUS, there's still no hydro prefix, so we know it must be a polyatomic ion, but that OUS indicates that it was from the ion that ended in ite. So that would be the sulfite ion, SO3 2-. So we have H+, and SO3 2-. We do our crisscross. There are 2 hydrogens, and of course only one SO3, H2SO3. And notice, since there's only one of each polyatomic ion, we don't need to use parentheses, and we should not put parentheses here. Then we have hydroiodic acid. So that hydro prefix, once again, tells us that it was an element. It's the element iodine.